Hello everyone, this is Lauren. Welcome back to the Easy Cloud series. Throughout the previous sessions, we have covered the basic concepts of cloud and AWS services so far. In the upcoming sessions, let's deep dive into AWS's 4 core services, which include compute, storage, networking, and database services. So, shall we begin with AWS compute services? AWS offers a variety of compute services. Let's explore some key options provided by AWS. First, we have EC2, Elastic Compute Cloud. EC2 functions like a virtual computer in the cloud, providing resizable compute capacity. This means you can easily scale up or down depending on your needs. Next, we have Lambda. Lambda is a serverless compute service that executes code in response to events. It's ideal for handling tasks without the need to manage servers. Moving on to ECS, or Elastic Container Service. ECS is a highly scalable and high-performance container management service. It simplifies the deployment, management, and scaling of containerized applications. Then, there's EKS, Elastic Kubernetes Service. EKS is a fully managed Kubernetes service, eliminating the hassle of managing the underlying infrastructure while making it easy to run Kubernetes clusters. Lastly, there's Lightsail, an easy-to-use virtual private server service designed for small businesses. Lightsail offers a straightforward way to launch and manage virtual servers in the cloud. These are some key compute services offered by AWS, each tailored to meet different needs and use cases. In this session, we'll focus on EC2 instances. Now, let's discuss how to launch an EC2 instance. First, you will need to choose an Amazon Web Machine Image, AMI, when initiating an EC2 instance. An AWS Machine Image, AMI, is akin to ready-made package containing everything necessary to create a virtual server or instance in the cloud. This includes an operating system like Windows or Linux, along with software programs and settings. You can use a standard AMI provided by AWS or create your own customized version, which can also be shared with specific AWS accounts. These AMIs can be launched in various regions and availability zones. Once you've selected an AMI, the next step is to choose an instance type that best fits your workload requirements. This involves considering factors such as CPU, memory, storage, and networking capacity. Amazon EC2 offers a wide range of instance types optimized for various use cases. These instance types are categorized based on their specific purposes, such as compute optimized, memory optimized, storage optimized, GPU instances, and more. Following the selection of the instance type, you proceed to configure the details of the instance. This involves customizing settings such as network configurations, security groups, and storage options. There are 2 mountable storage options available for EC2 instances: Amazon Elastic Block Store and Instance Store. We'll cover the details of network settings and storage options in the upcoming sessions. Let's take a closer look at how to identify EC2 instance types. By examining the name of an instance, you can often determine its EC2 type. The name typically comprises two main parts: the instance family, for example, T2, and the instance size, like micro. The instance family groups similar instance types in terms of performance and pricing. For instance, T2 represents general purpose instance with burstable performance, while the number following denotes the generation, with a higher number indicating a newer generation with better performance. The instance size indicates after the family name, like micro, reflects the instance's capacity or resource intensity. Other size options may include small, medium, large, extra, and so on. In summary, the EC2 instance type determines the virtual hardware of the instance, while the instance size specifies the amount of CPU, memory, and storage capacity. By combining the instance type and size, you can discern the performance profile, capabilities, and pricing model associated with the specific EC2 instance. If you've selected an EC2 instance, you can start it. Here are the three main stages of an EC2 instances. First, running. The instance is up and accessible, and you can use it as required. Next, stopped. The instance is turned off, but the data on its EBS volumes remains intact. Lastly, terminated. The instance is permanently deleted and its resources are released. Once an instance is terminated, it cannot be restarted. Then, how do EC2 instances communicate internally? Each instance receives a private IP address within the virtual private cloud, allowing interaction among instances within the same VPC. Additionally, EC2 instances may possess public IP addresses for internet connectivity, and elastic IP addresses provide static public IP addresses for consistent access even after instance reboot. Security groups act as virtual firewalls, manage inbound and outbound traffic according to predefined rules, while network access control lists regulate subnet level traffic within a VPC. These networking features ensure secure and efficient communication among EC2 instances and other components within an AWS cloud infrastructure. Now, let's learn about some fundamental features of AWS's EC2 instance: auto-scaling and load balancing, contributing significantly to the efficiency and reliability of applications hosted in the cloud. Auto-scaling enables EC2 instances to dynamically adjust their capacity in response to changing demand. When there is a surge in traffic, auto-scaling automatically provisions additional EC2 instances to accommodate the increased load, ensuring that the application remains responsive and available to users. Conversely, during periods of low demand, auto-scaling can scale down the number of instances to optimize resources utilization and minimize cost. In conclusion, with auto-scaling, load balancing plays a crucial role in distributing incoming traffic across multiple EC2 instances or containers. AWS Elastic Load Balancer service intelligently routes requests to healthy instances, preventing any single instance from becoming overwhelmed. Within the ELB service, two key load balancers are the Application Load Balancer ALB and the Network Load Balancer NLB. ALB operates at the application layer, layer 7 of the OSI model, making routing decisions based on content such as URL or HTTP headers. It is well suited for applications requiring advanced routing capabilities such as path-based or host-based routing. On the other hand, NLB operates at the transport layer, layer 4, and is optimized for high-performance applications with large volumes of traffic and low latency requirements. So, together with auto-scaling and load balancing, you can run high-performance, scalable, and resilient applications in the cloud. You can utilize AWS CloudWatch to effectively monitor your EC2 instances. CloudWatch allows you to set up alarms to track important metrics like CPU usage, network traffic, and disk activity. When these metrics surpass predefined thresholds, you will receive notifications. Additionally, CloudWatch logs let you gather and monitor logs from your EC2 instances, offering insights into application and system performance. With CloudWatch dashboards, you can customize your view of EC2 metrics in one place, while CloudWatch events automate responses to system events. By leveraging these CloudWatch features, you can manage and monitor your EC2 instances' performance. Alright, we covered AWS Compute Services, specifically focusing on AWS EC2 instances. We've discussed how to select the appropriate instances for your workloads, along with essential features and monitoring methods. In the next session, we'll explore other AWS core services. See you all then. Thank you and goodbye.